All right, so yeah, let's get going. The first talk in this room is Andy Fundinger talking about adventures in not testing.
I gotta turn this mic on. There we go. Okay, so welcome. Welcome back to PyData last day. First talk after the keynote. So who am I? Hi, I'm Andy Fundinger. I've been programming Python. I think it's more useful to give you a version than a year. So I've been working, I started with Python 2.4, and I started with a book that said, Learn Python, version 2.2, newly updated for Python 2.3. So at the time I was working on Clone, which is a content management system for my company at the time. I've done some stuff with Twisted, I've done a lot of stuff in the financial industry. About 2017, I came over to Bloomberg. Initially I worked with a product called Data License. It's basically, would you like Bloomberg data? Here's Bloomberg data. About 2019, I caught a hint of the system reliability engineering, and I said, oh, that looks interesting. I can fix things that are broken and figure out what's broken, which just appeals to me. And then in 2020, I went over to our data services group, which is really very similar. It's, you're in Bloomberg, well, you're in Bloomberg, you want data, get data, we'll give it to you. So we run a data gateway, kind of sits in the middle of many Bloomberg workflows. We're a gateway, we don't own the code above us that asks for data, we don't own the code below us that gives us data, we own the getting the requests through. And there's a lot of requests, there's billions of requests a day. There's millions of semi-independent code paths through code that we don't actually own. So a lot of what I do is I take in telemetry data, I take in information about what the system seems to be doing, and I try to make progress from there. So that's a lot of analysis. We'll talk about that because that's where we're going. But about this talk, first of all, show of hands, who only read the title and decided to come to this talk? Okay, you're going to have a slightly different experience from the people who read the title and the description. So this talk is about how to not write tests. But really, it's about how to reduce the time we take to write tests with a couple tools that I think are useful, and I think are very useful in and around data science and analysis code. So despite the title, we will be writing tests, we will be creating tests, but we will get some help writing them. So I'm gonna refer to my main example as analysis code. What I'm talking about is where you start with a question. Questions that I get are like, what does latency look like? What do we rely on? These are questions in human language that don't have specific, like, I'm going to use this methodology, I'm going to do this, I peer reviewed what I'm going to do, I know what I'm going to do. So we don't know what the answer is, we don't know what the question is, and we might only need it once because we're going to discuss it at a meeting and then make some decisions. Sometimes it makes sense to not write tests while you're writing this code, because you're doing some averages, you're looking at like the 99th percentile, and then you're like, oh no, maybe I should look at the 90th percentile, until you get something that explains what you're seeing. And that's your answer, and you're done. Of course, once you've done this, it's not uncommon that someone's going to look at it and go, so, could you make a little change in this? Could you run it on a subset? Could you group by, like, heavily loaded versus lightly loaded? Could you run this every day on the day's data, output the information, and send it around for the whole company to look at? At that point, you already know you should have tests. So this request brings you from, it didn't make sense to write tests, to I should have written tests. And that's kind of the pit that I want to suggest a way out of. But we still don't know what the future data is going to look like. We neither know what we might be asked to run in the future, nor what data might actually come in because it's the future. So, the example code that will pop up from time to time here, I just generated 10,000 samples of some kind of requests. And I used the loose question, how would the system perform at various capacities? I said, okay, some clients are batch, some clients are timely. If it's a batch client, it could roll over. And the thing we think is interesting is how long is the system 100% loaded after you take what came in and what's rolling over. We will never actually look at the full code, but some people I think will better understand if they're not worrying about what the code might do. And the main tool we're going to use is hypothesis. Maybe we'll do show of hands again. How many people have heard of Python hypothesis library before? Oh, cool. Okay, great. So this is copied right from their website. Basically what hypothesis does is lets you say the data should look like this. And then it should run through my test and I have some idea what happens. So a normal test, you say, I'm going to set this up, I'm going to create this input. Okay, that's great. Then I'm going to run it through this code, and then some things will be true. Also, it won't crash. Hypothesis says, I'm going to say what the data should look like. Hypothesis is going to create hundreds of variations of what I said the data should look like. It's going to run it through this code. A, it shouldn't crash. But B, I can make some assertions about what should always be true, either based on the data that came in or based on what my analysis is supposed to do. This is also known as property-based testing, and it originated with the quick check library in Haskell. So, how does this help? Well, it relieves us of having to create test data. So, if we create test data, we're going, okay, so what does the data look like? Okay, let me make something that looks like the data looks like. And we're not going to create the, what kind of data would cause this error? What's the weirdest thing that might get sent to us? What did I say should work, but like, no, we're never going to get a negative net sales in our cash registers. That wouldn't make sense, so you didn't put in the test data. Well, we don't have to make those decisions up front. We can tell hypothesis. We take floating point numbers. So we describe what might be valid and we let hypothesis work it out from there. So this is the hypothesis floating point number strategy. Here's an example. You said it could take floating point numbers. Can it take 10 to the 308? Let's take another example. How about 1 to the negative, 1 times 10 to the negative 7? Oh, and it's negative. You said it would take floats. How about not a number? Is that a good float? Hypothesis will take care of making sure that it feeds those in eventually. And in fact, hypothesis is almost pathological. So it will go, hey, how about infinitesimals? How about 10 to the negative 308? How about if everything in the input is infinity? But we're still writing tests here. And I said we were adventuring and not writing tests. I have to get at least partially there. Hypothesis has a tool called ghostwriter. It installs a script called hypothesis. When you pip install it, hypothesis.write, it writes tests. And how it writes tests, you give it a Python function or module, and it writes the test for them. So here is a hypothesis test for sorted, written by a ghost. Hypothesis write sorted, and this is what they look like, given an iterable, which is either a sequence of integers or a sequence of floats. Sorry, sequence of integers or a sequence of text. Given a key, which is a key function, but the type hinting in the standard library says that's always a none, and we won't fix that on this example. And given a reverse, which is either true or false, we should be able to run sorted, and it should all work. So it writes hypothesis, feeds in data, there are no assertions. The ghost cannot know what your code's supposed to do, other than not crash, which may be an improvement. Let's take another example. This is what you get if you try to run on the math ceiling function. We should know what ceiling does. But they didn't type hint it. So it says the strategy is nothing. Strategy nothing fails test, right off the bat. But it did go ahead and create the boilerplate code. We can fix this. Ceiling takes floating point numbers. And now we can say, we assert, no matter what number you take, if you get the ceiling of it, your output will be greater than or equal to the input. We could make some more assertions, but this will be true. And now we can run it. And this is run through PyTest, and we get not just one failure, we actually get 2 failures. It turns out you cannot convert not a number to an integer. It raises a value error, and infinity raises an overflow error. So we would then go and say, okay, well, this is the proper behavior. I mean, I picked something from the standard library, so I'm not going to fix the code, but I do need to fix the tests. So now I would say, hypothesis test with given. Do not take not a numbers. Do not give me infinity. Those are not valid for this test. And add 2 standard tests below that say, if you are given a not a number, then you must raise a value error. Okay, so we'll go ahead. I've got one more here. This is just to show how it writes out. Group by also takes iterables and runs. Moving into something that might be our code. Now I'm gonna apologize for our code here. I went on vacation to Portugal, and I made sure to write it when I was really relaxed, so I would be sure there were bugs in the code. So this is a function that I came up with, again, on vacation, for finding the longest, how many trues and how many falses there are in a row. You can write a better one. But this has bugs, and that's good. So it's type hinted. I said this takes an iterable of bools, and it does its thing. Should I have people raise hands if they can see the bug in here? There is a bug? Okay, well, hypothesis will show us in 2 slides. But first it'll create us a test. Here's a test. These are all the different things that iterables could be. Now, I actually feed this pandas series, pulled out of a data frame. But these are all different iterables, and I type hinted it to say iterables. So all of these should work. Hypothesis will test all of these. And when hypothesis does so, key error, false. If you actually feed it an empty sequence, there's no true or false back here. Sure, because I was going to write a test to feed it an empty sequence for something I never expected to send an empty sequence because I got 10,000 data points. That was on my list. So here we'll probably fix the code. I'm sure there's a bug still in this, and it's certainly inefficient, but that will return, if there were none, then it's 0. But these sequences are all well and good, but we use data frames an awful lot. So let's try data frames. Yep, there we go. It read my type hinting, it saw it was a data frame, it said, here's a strategy from type data frame. Go ahead, use that. This will create data frames and it will feed them in. And it will find an error in this function because it turns out if you take an empty data frame and you tell the code to sum up along a list that has something in it, it will notice that the column's not there. And that's a failure, obviously. So we should probably fix that. There's the code. But let's take a look at this from type strategy. If we just run this from type strategy, we can get an example and we can see what it gives us. It gives us an empty data frame every time. Well, that's not going to get us very far. We could have just given it an empty data frame. So we'll make our own data frame with columns and data. So we can do that. Winds up being quite a bit of code. So I changed my test. I said my test takes a list of client names, takes a list of floats that are going to fill into the data frame, takes a list of true false are these batch, takes those, puts them together, looks at the true false to make the list of batch clients that it has to send in, then it knows what the clients are, so it can use the clients and it can fill those float values in row by row to make up a data frame. Yeah, we can do that. And it works. There's one of the test data frames that's created by that method. I probably would find some bugs. I doubt that I'm set up for those infinities and not a numbers. And we can even make some assertions about it. So this is just cutting off the bottom of that test function. We can assert, and whatever the total is, it's the sum of the batch and the timely traffic. Whatever that is comes up to the total, summing across the whole data frame. It should all sum out somehow. Well, we can make the assertion, hey, the max total should be higher than or equal to the batch max, and same thing for timely. That all makes sense because, where was my code? At the end of the day, this is the function we're expecting, calculate totals for batch, timely, and total. So we'll go ahead and run this, and yeah, we got a couple assertion errors here. First of all, if we get a not a number, and we try to add something to the not a number, you can't make a comparison anymore because you can't compare not a numbers. Also, you can't compare two not a numbers if everything comes up empty. So, I'm sorry, the first one is not with not a numbers. The first one is if I feed infinity and infinity, even if you add up infinity, it's not a number and you can't use it. So, infinite usage is probably not a thing. I don't know. I'm making the assumption that I will not allow infinite usage into here because it's not clear what one would do. So I can go and I can say allow infinity false. Feed this in. And then I'm going to make the other assumption that if I get a not a number, I want a 0. So I'll go ahead and change now my code to say not a number. I'll also say if I get batch clients that are not even in the columns, that's fine. I'll only work on the ones that are in the columns. That'll solve that earlier error. And we still have one more bug here. It turns out that if you have a negative number, it will not, you can get a maximum total of -1, and your batch can be 0. So we're also going to say that we don't let negative numbers in here because we know what our input source is, and we know that negative usage is not a thing for us. Now we have a test, but we're not going to keep doing that. Hypothesis extra pandas can let us just create data frames out of whole cloth and with the help of hypothesis. So the different function estimate needed capacity. It only actually looks at the total column. So we say pandas data frames columns. We define one column. Its total data type float 64 there. And then we take a percentile. Now percentile only makes sense between 0 and 1. So we can go ahead and define that right off the top. Now we have a function and we can run it. And you may have picked up the pattern in this talk. Almost always the first time we run it, we hit a bug. In this case, if you calculate the percentile of an empty data frame, that's also not a number. So again, we'll make a check. We'll say if it's empty, return 0 and move on. Okay. Another case that we run into is sometimes you'll put together the data, and what you put together when you look at it with the tools you have available up in Given, you're going to create something that doesn't make sense. And hypothesis gives us an assume function for that. So we have a function that's called enrich capacity. We're looking at the capacity of something, again, a made-up example, but it's not interesting if we have plenty of capacity. We don't need to test, what if you have infinite capacity? You don't. You don't need to test if you have capacity far in excess of your usage. So we put this together with total, batch, timely, same as the output of the earlier function. And we're just going to assume the capacity is at most 10% more than the highest number in the whole data frame. Because if it's more than that, it's all going to be the same. You can also use this to skip something that you know will fail because it doesn't make sense. And we're winding down here. There's a couple hypothesis tools I want to mention, but I am not demonstrating. There's target and example. Target will let you say, please run tests like this. Example will say, include this one. Of course, you could just write a separate test to do that, but these are useful for reproducing things, especially if something failed in CI or on someone else's desktop and you want to make sure that that one's being run. Because otherwise, hypothesis is following a couple processes. First, it's randomly doing some things. It's including anything that failed previously because it keeps a cache, so you will not escape your failures with randomization. And then once it found something, it makes some additional runs to try to narrow it down and find the simplest example. there's also register type strategy. What register type strategy will let you do is if when you type hint, you use a type definition, and create a new type, you can say, this is how you create these. So if you have a final customer usage data frame or something, you can say that's the type, and then Hypothesis will create that for you. There's also settings for timing and randomization. So you can say don't randomize, just always run what you would consider from this seed or something. Timing is one I wind up using a fair amount. If you're testing something complex, you can tell Hypothesis, yes, you raised an error because running this test took longer than Hypothesis defaults to, but please just keep going. I know it's taking a long time for my tests, but it's worth it to me. So, conclusions. Do write tests. Do use test-driven development where appropriate. If you know something is going to be used, if you know what you're doing, go ahead and write the test first. It's probably less hassle upfront even than anything that can be done here. However, do go ahead and use Hypothesis rather than or in addition to selected examples. All of this is driven off your type hints. It's probably worth it. At the same time, you're putting in documentation, put in type hints, let Hypothesis make some tests off of those. And of course, the big takeaway here is if you don't know what data you might get, Hypothesis lets us describe everything that could be valid, should be valid, and then we'll run the test off of that. And this brings us down to Q&A. So. Somewhere there's a microphone.
Yeah, but let's see. Does this? If I turn this on, let's see if it's. Is yours on?
I think so.
Okay, cool. Any questions?
I'm wondering if there's a way to specify a maximum number of tests that Hypothesis will run.
Yes. I think it's mostly specified in terms of time. I think by default it comes out to it's either 100 milliseconds or half a second that it'll sit there just banging away. So you would say like, okay, I only want you to run 10 milliseconds on this. And it splits the time in half. The first half it uses to find tests. The second half it uses to narrow down to the best example it can give you.
Thank you.
If I can just yell.
Go ahead.
Is there any way for Hypothesis to, say you want to run the same test run 3 times with the same inputs into Hypothesis and then have it randomize again? Or is it on every iteration that it randomizes it?
So the question was, as I understand it, if you want to run the exact same code with the exact same input 3 times, because something is non-deterministic beneath that?
Yeah.
Okay. It wouldn't surprise me if there was a setting for that, but I'd probably just put a for loop in my test.
That's true.
It sounds like there's, thank you for this. So I think you can create your own custom strategies, but to what degree do you usually end up doing that? And kind of related to this is the little that I have tried to use it and dealing with like scientific computing, you want to like maybe define something drawn from a distribution, and it wasn't at least immediately apparent to me how to tell it to like make distributional assumptions in what it generates.
So essentially when you're making a data frame, as I showed, you are defining your own strategy. You're essentially defining your own strategy for creating your data frames right there. So I do that a fair amount. I've been using this basic approach on my own work for like 6 to 9 months. much is true. If I need something to conform to a distribution, I would probably use an input like of a seed, which is a float, and just feed that seed into something that creates that distribution for me. I think there is a statistics extension similar to the pandas extension, which may, for the more common distributions, may be fine if you're looking for a normal distribution or something. But I would probably just create it in a test.
Any other questions? Going once, going twice. Cool, let's thank the speaker again.